Hello, my name is Jeff Randau, and I am the TA in charge of the SDN Firewall project. I was also the TA that was responsible for the virtual machines and the simulating network project. So if you have questions about those, feel free to ask me. Also, you may still submit the simulating network project if you want to, just to get some mini-net experience. Well, this project involves a simple demonstration of software-defined networking by building a trivial firewall using OpenFlow and the POX OpenFlow controller module. By simple, I mean that this project just briefly covers the capabilities of a software-defined network. In order to go deep into software-defined network will take a lot longer than we have to do this project. The code that you use in this project could be expanded to, for instance, redirect traffic, respond to network abnormalities, or other responses based on a particular set of input values. Like I said, this firewall will be built using the POX OpenFlow controller. This implementation will take a set of parameters that you provide from an input configuration file. It will match different IP and application header parameters, and you'll decide what to do with the traffic depending on if you were to block or allow it. That's all. The documentation for this implementation is provided in Appendix C of the project description and has everything that you need to know to build the implementation. But I do want to make a few comments about this implementation. 1. You do not need to handle the import of the configuration profile. The entries in the configuration profile are provided to you in your code by a dictionary object. All you need to do to handle these entries is to determine the appropriate type for the item and whether or not you need to match it. You need to decide whether you need to match an object. And also in this same vein, do not attempt to alter the setup firewall.py file to add more validation of your input parameters. That file is not, you will not provide that file back to us in your submittal, and the autograder has its own version, so if you make a change to the code there, it will not take effect when you are being autograded. 2. The most common issue that people have with implementation is that they make their code too complicated. My advice is that if your added code exceeds 20 lines, please rethink your solution. And also realize that the Python that you'll be using is probably going to be very simplistic. Yes, it is okay that it's simplistic. It does not need to be complicated. If it's complicated, you're probably making it too difficult. 3. Do not attempt to use the debugging or the coding help provided by editors like PyCharm or VS Code. There is very little debugging necessary for this project, and also POX is an external module, so it's not a part of the normal Python standard library. So VS Code and PyCharm will have a hard time building documentation and autocomplete for it. And also do not try to import pip import POX or pip import POX because the POX library is not, the POX library that we use is not the one that PyPy has for POX. So just do not re-import it. Do not pip install. And then 4, please don't use the POX documentation that you'll find online. It may lead you down paths that will make everything much more complicated. The Appendix C documentation was modified from the original to remove things that do not work or just try to lead you down paths that will cause frustration. Now, I will talk about other particulars after I describe the configuration profile, but first I want to encourage you to do some research about the contents of an IP header of a data packet, and also the application headers for the TCP and IP protocol, since they have an additional header to the IP header. we will use the data contained in these packet headers to determine if a particular packet will need to be blocked or allowed. One aspect of this project includes a Wireshark tutorial. When you do this Wireshark tutorial, you will see the headers and find the different parameters that you'll be using for matching. Evaluate carefully how the different traffic is generated. For instance, what are the parameters when the client is requesting data from the server compared to when the server is responding to the client? You will need to understand this behavior to help build some of the rules that you'll need to complete the task in Part 5. Now let's talk about some of the parameters we're dealing with. We want to have the ability to specify these parameters to use in identifying traffic that we would like to allow or block. We will use this to build our configuration file. These parameters involve the data needed to completely identify the host, so for instance an IP network address or a MAC, which is a hardware address. You will also need to know the internet protocol for the traffic, TCP, UDP, ICMP, GRE, the ESP. Those are the different internet protocols. And for internet protocol 6 and 17, which 6 is TCP, 17 is UDP, you also need to know the application port number that we need to use. These define 7 of the 10 items that are in the configuration file. The other 3 parameters involve a rule number that you'll assign to a rule that you only use. Do not use that rule number for priority. It's just there to help you when you debug. If you have an invalid rule, the code will tell you, the program will tell you that you have an invalid rule number X, so you know where to go back and look. The next parameter is either the word allow or block. So by default, this firewall will allow all traffic. It does not do any blocking by default. You will then need to build match objects that will basically to match the traffic that you want to block. And then you'll use the block instruction to block those connections. However, let's just say that you want to unblock an entire subnet, but you want to allow one particular host in that subnet to connect, or to basically allow the connection. You would use the allow parameter in that option to pinhole that one connection that will bypass the block rule. So basically, think about block covers a big segment, and you want to allow one particular part of that segment to actually work. So that's when you use the allow option. Basically, allow will always override a block, but if you didn't block traffic in the first place, there's no reason to write an allow. So if the rule says make sure the entire internet can access something, you don't need to allow that. You only need to allow it if you block something. And the final field is a comment that basically you put there to help you figure out what you're trying to do with that rule. Just a comment. It's not used. Rule number is not used. They're just there for your help. So this configuration policy, combined with your implementation, will build the firewall. As I said earlier, your code should not need to be greater than 20 to 30 lines. Likewise, you should only need about 21 lines of rules to satisfy the requirements from the project description. This project is simple, but it requires more thought in what you're actually trying to do. If you do not understand packets and the concept of how connections are made, you will need to study the packet captures to see what's happening. That's the reason why the Wireshark is a part of this project. In theory, the coding and the configuration implementation for this project should take no more than 2 to 3 hours total, and maybe 2 hours for manual testing. Do not feel bad if you don't get the concepts immediately. The Python code is very simplistic. Most people get bogged down because they make the code more complicated than it needs to be. For instance, there isn't much of a need to use dictionary comprehensions. In the past, people making mistakes with dictionary comprehensions have caused most of their lost points. Also, in Appendix in the project description, there is a section in Appendix B that talks about the different things that you need to look at to help you troubleshoot your implementation if you get an error message, what to do with the error message, why is this happening, if I see a prerequisite error, what does that mean? So look at that Appendix B to figure out what's wrong. Most of the common error messages have been put there. And then after you have done your implementation and configuration, you will then want to test your submission. And actually, you'll probably do this when you're building the project. Appendix A describes how to test your submittal manually. And there's a YouTube video that I made about 2 years ago that demonstrates this. That's when you actually create your client and your server tests and try to see if they work. In addition, there is a test suite that's contained in the project files that comprises a 2 tests. The first one will test to make sure that your firewall works with the rules given in Part 5. This is what the autograder will use. In fact, the autograder will run this exact test 3 times. First, with your configuration and a known good implementation of the firewall code. Second, it will test your firewall code with a known good configuration, and then finally your implementation with your configuration. Mainly that's done if you can't complete the project, you can get credit for the sections that you did complete. So if you were only able to do the implementation, you'll get credit for that. If you're only able to do the configuration, you'll get credit for that. Just to help people who run out of time. And then there's an alternate test suite that's in the ALT folder, and this is not being used by the autograder. It's there to help you test your implementation. It includes a different topology, and it includes it's a known good configuration file, and it has its separate set of rules that are not related to what's in Part 5. But this will help you if you pass all the tests of the alternate test suite, and you're still having problems with the main test suite, that will tell you that your problem is in your configuration file. Because if you pass the alternate test suite, it tells you your implementation is 99.9% good. And that's basically it for this project. There are videos online to watch. Come to the TA office hours and the chat sessions. We will help. Do not procrastinate. Do not procrastinate. Waiting until the last weekend is a very bad idea. There are concepts that take some time to understand, and people in the past semesters have said that after about a day or two they get the project, they can get past the hurdles of learning about how the network traffic works. So if you try to do that all on the Sunday before the project's due, you will not have a very pleasant outcome. And above all, have fun. This is supposed to be a fun demonstration project. So good luck, everyone, and I hope that you enjoy this project. And like I said, if you have any questions,